Hello everyone, I'd like to welcome you to this video titled Writing Inequalities. And for this video, you will need to get out your Go Math book and turn to page 319 and get out your math journal and a pencil. Now the goal for this video is for you to understand how you can use inequalities to represent real-world constraints or conditions. Okay, so we're going to take a look at a couple of these different meanings or a couple of these different phrases and see what they actually mean. Okay, so what we can understand first of all is that you can use inequality symbols with variables to describe quantities that can have many different values. Okay, but before we understand that, we need to understand what these different things mean. Okay, so we're used to the symbol of the greater than or less than. Okay, so we see this as the less than, means fewer than or below. This symbol here means greater than, more than or above. Not too difficult here. So when we're thinking about 8 is less than 9. Okay, so we use that symbol. Or we could say 9 is greater than 8. Now, some symbols that you may not be familiar with, okay, are some of these other ones here. What we have here is this little line. That means is less than or equal to. So same way, so less than, but that little line means or equal to. Again, same symbol going the same way is greater than or equal to. So whenever you see these lines underneath the greater than or less than symbol, it also means or equal to. Okay, so less than or equal to, greater than or equal to. That line means that. So that's really important. Just think about that line means or equal to. That'll help you out for that. Okay. Now, we can see that on page 319, so it will be important to understand these different symbols. And if you don't understand the symbols, it's going to be hard for you to understand the rest of the lesson here. So that'll be really important for you. Now, let's take a look at graphing the solutions of an inequality. Now, a solution of an inequality that contains a variable is any value of the variable that makes the inequality true. Remember solution, okay? We talked about solutions with algebraic equations. Okay, so for example, a plus 7 equals 11. A solution to that would be a equaling 4. Okay, so solution of inequality kind of represents the same thing. Okay, so we see um, solution, any value of the variable that makes the inequality true. For example, 7 is a solution of x is greater than -2. So we could say that x is greater than -2, and the solution would be, 7 would be the solution there. And since 7 is greater than -2, then 7 would be a solution. All right, now you can see there's a lot of solutions for this. Okay, it wouldn't be just 7. You could say -1. You could say 0. You could say really an infinite amount of numbers could be greater than -2. But saying that 7 is a solution, yes, that is true. Is it the only solution? No, it is not. Okay, so it's important to understand that. All right, so we're talking about finding some solutions here of the inequalities. Now, you can see there on page 320, it's telling us now to graph the solutions of each inequality and then check the solutions. So we can see for letter A, what that means is that y is less than or equal to, okay, understand that line there, means or equal to -3. So how do you go about solving this problem? What you do is you draw a circle at -3, a solid circle, to show that -3 could be a solution. Remember, it means or equal to, so -3 could be a solution. And then what we do is we shade the number to the line to the left of -3 to show that the numbers less than -3 are also solutions. So y being less than or equal to -3, so -3 could be a solution. Why is that? Because it's equal to -3, and all the rest of the numbers to the right of the number line would be a solution as well, because they're also less than -3. Now, if we're trying to figure out a solution, what we could say is we want to choose a number that is on the shaded section of the number line, such as 4 or -5 for a solution. So if we were to say -4 is a solution to this inequality, that would be correct. We could say -5 is a solution to that inequality. So on the number line there, it is less than -3, less than or equal to. We could even say -3 would be a solution because it's equal to that one as well. So you can see whenever you see that less than or equal to sign, what you're doing is you're finding that number, that -3, you're filling in the circle representing that it is a solution, and then also graphing the rest of the number line there. And we'll go through some of these together a little bit later. Next one, this says 1 is less than m. So with this one, we don't have that equal to or equal to sign here underneath there. So we don't draw the shaded, we don't color in the circle there because it's not a solution. So we start at 1 and we shade everything to the right for this. Okay, so that means all these numbers to the right are greater than 1. So we could say, check your answer there, substitute 2 for m. So we could say 2 would be a solution. Why is that? Because 2 is greater than 1. We could say 3 is a solution. 4, 5 is a solution. 1 would not be a solution because 1 is not greater than 1. It's equal to. All right. So let's take a look at some of these examples here. And these examples are on page 323 in your Go Math book. So for number 6, it says, which of the following numbers are solutions to x is greater than or equal to 0? So they're just asking which of these would be a solution to this one. Okay, so for this we have 0. Why is that? Because it's equal to 0. All right, we also have 0 and 3/100ths because that's greater than 0. And we also have 1 and 5/10ths. So those three are all solutions. Oops, I'm sorry, didn't see that 1/2 there. Finally, the 1/2. Those are all solutions that could be part of that x is greater than or equal to 0. All right. Now, talking about solutions, we see that that's any number that can be plugged in for that variable for the inequality and still make it true. Okay. Now, let's take a look at the problems on 323 together. Let's take a look at number 7. So what this reads is that t is less than or equal to 8. Okay, so in order to graph this correctly, what we do is we go to 8 and we color in that circle. All right. And then now that we've colored in that circle, it's saying that t is either 8 or less than 8. So we got to color in everything, shade in everything on that number line that is less than 8. Okay, and that means it's going to keep going. So all these numbers would represent a solution to this inequality. Okay, so again, that line underneath the greater than or less than sign means you need to shade in that circle. If it does not have a line underneath it, we don't shade it in. So let's take a look at this. We have -7. So since it's not a line there, we keep that circle open. The reason for that, it shows that -7 is not a solution. When you close the circle, that shows that it's a solution. So -7 is less than h. So we have our circle there. Then we shade everything in that's greater than -7 to the right. Keep on going. I know I'm not doing it so pretty, but that's okay. So this is a way that you graph the inequality. In other words, we keep the circle open. Why is that? Because it doesn't have a line underneath there showing that -7 is not a solution. Let's take a look at number 9. We have x means it's greater than or equal to -9. Remember that line underneath that greater than or less than sign means or equal to. So the first step is we go to -9 and we color it in. Why do we color it in, that circle? Because it's showing that -9 is a solution. And then what we do from here is we're saying that x is greater than -9, so we're going to graph everything in, shade everything in to the right, I should say, of our number line, showing that all these numbers to the right are examples of solutions to this inequality. Finally, number 10, n is greater than 2.5. So we go to 2.5. We do not color it in. The reason why we don't color it in is because 2.5 is not a solution. And now what we do is we just graph this to the right, showing that everything to the right of 2.5 on the number line would be a solution to that, because that means n has to be greater than 2.5. So all of these numbers to the right could be possible solutions to this inequality. Now what we're going to do is we're going to do the opposite of what we just saw. So it's saying for us to write an inequality that matches the number line modeled. Okay, so we're going to use the variable x. That can be one that we'll use. And you really need to look at what number it starts at. So we have that 6 for this one. And think about everything that's shaded to the right is greater than 6. Okay, so because of that, we're going to say 6 is less than x. All right, and how do we know that? Because everything to the right of 6 is colored in or shaded in. That means 6 is less than everything to the right. We don't put a line underneath it because that circle is not shaded in there. All right, let's take a look at number 13. Let's do this together. So for here, let's just do x as our first variable. Now what is x? We know x is less than our -3. So we have, really when you think about it, you can have x and -3. You can even write that first. Why do we know that? We know we have a variable, and we know that -3 is our number where we started. So that's the number that you always write wherever the circle is colored in or not colored in. Now we know that x is less than -3, and we also know that x is possibly equal to -3 as well. Why do we know it's possibly equal to it? Or equal to it? Because this is shaded in. In other words, it's showing that -3 could be a solution to this inequality. So x is less than -3. Why do we know it's less than? Because everything shaded in to the right of -3, I'm sorry, to the left of -3 is less than -3. Let's take a look at another one, number 14. So we're going to write x, and we're also going to write 1.5. And then our question is it going to be the greater than, less than, greater than or equal to, less than or equal to? Now we know this circle is not shaded in, so that means it's either going to be greater than or less than. That's it. It's shaded to the left of this number. Everything is pointing towards the left. So because it's pointing towards the left, we know that x is less than 1/2. That's what this represents. All this represents x, and then we know it's less than 1/2 there. Finally, looking at the final one there on page 15, again, we're going to have x, and then we have -3.5, all right, so for number 15, we can see that everything to 3.5 is shaded in. That means x is going to be greater than 3.5, and it's colored, and that circle is colored in. So not only is it greater than, but it's also could possibly be or equal to. Okay, so whenever that circle shaded in, you put a line underneath your greater than or less than sign. So now we're going to take a look at some real world problems to model, to write inequalities about. So it says a child must be at least 48 inches to ride a roller coaster. So it says graph an inequality to represent the situation. So the key word here is at least, okay? So that means you can be 48 inches or taller to ride the roller coaster. Okay, so in other words, greater than or greater than or equal to 48 inches. So because of that, we're going to color in that circle, and then we're going to graph or shade in the rest of the number line there. So what this represents is this could be C for child, has to be greater than or equal to 48 inches there. Now, thinking about a solution, can a child who is 46 inches tall ride the roller coaster? Okay, and we can say easily that no, the child cannot, because in order for it to ride, not it, but in order for the child to ride the roller coaster, has to be 48 inches or taller. Okay, so the 46 would mean that the child is shorter than the required height. Let's look at number 17. We'll do this together. So it says the stock is worth at least. Okay, so when you see the word at least, that's showing that it's going to be that or equal to part, worth at least $14.50. So what we could have here is the stock is worth at least that, and then we have 14.50 would be the inequality. So in other words, what we do is we go to the 14.50, we color that in because it's greater than or equal to, and then we shade in to the right. So it's worth at least 14.50, could be worth more. Number 18, the temperature is less than 3.5 degrees Fahrenheit. So what we can do for this, we have the temperature, it's just less than, that's it, 3.5 degrees Fahrenheit. Okay, so what we do is we find 3.5 degrees Fahrenheit, or 3.5 on our number line. We keep that circle open, showing that it is not a solution, and then we shade in the rest of our number line there, representing all these numbers here could be a possible solution. Number 19, the goal of the fundraiser is to make more than $150. So what we could do is the goal, so it's going to be more than, not at least or more than, more than. So it's going to be the goal is less than, the goal would be greater than 150. So what we would do, we would find 150. We do not shade it in because there's not that line underneath the greater than sign. And we color in the rest of our graph there for representing that any of these numbers on here could be the goal. So that concludes the video on writing inequalities. If you have any questions about this concept, please come and see me.